Hi everyone at home. We're moving on to our last topic of our first part of our light and optics unit. And this lesson goes along with this sheet right here where it gets centered there. More about refraction. Now we've talked about reflection where light bounces off of something. Now we're going to talk about refraction where light travels through something but something happens while it travels through that thing. And that's what we're going to talk about. So you can take down notes if you want, or you can just listen. This is going to help you understand your worksheet a little bit better. So let's start by getting a definition of what refraction is. I need to do more typing, Chloe. Alright, so refraction is when light moves through different media. Now what the heck is a media? It's not the news, it's not the TV, it's not the stuff you find on your phone. Media, when we're talking about light, is just something that it can travel through. You can think of media like things, light passing through different things. Light passes through the air around us. It passes through the glass in the windows. It can even pass through water when you go swimming so you can see. So let's give a couple of examples. Air, water, glass, etc. So as it passes through those different things, it moves at slightly different speeds. And that has to do with the density, or how many particles are inside each of those different objects. At those different speeds, it makes it bend. So let's read that last sentence again right here. As light passes through different media, it moves at slightly different speeds because of the density, which makes it bend. And that last part, making it bend, is what refraction is. So that was when light bends as it passes through something. Now we kind of have two options, or two different ways in which it could bend, and because of two very different things. When light is moving through something that is not very dense and hits something that is more dense than it, it is going to slow down. But if it is going through something that is dense and enters something that is less dense or has less particles in it, it can actually speed up. But let's take a look at that first one to start. Let's take a look at, I'll do some color coding here. Let's do blue. We always like blue. When light enters a, I'll change a, pardon me, a more dense medium, it, drum roll, slows down. This actually, the speed that it is traveling at, it slows down. And to show this, we're going to do one of everyone's favorites, ray diagrams. You should love these by now, so let's start by giving us a shape of something that it can travel through. And on this one, we're going to have an arrow coming towards our object. And if you remember back, the name of this beam of light that's coming in, that's going to be our incident ray. This is our incident ray that's coming through. Now let's take a look at what it would look like if these were the same density. So if it was not going to bend at all, you can just imagine that the light would travel right in the same direction that it was going, and it would keep on that path. But from what we've been saying so far, we know that's probably not the case. Before we go further, we got one more note that we got to add on the side here, and that's talking about what happens. So we know that it slows down, but we don't know where it's going to end up bending. colors here. Slowing down means bending, here's the kicker, towards. There's going to be another word that we've looked at so far, the normal. So the normal, remember that was that line that was right in between. So if this was reflecting, we know that the light would come off here, and that magical line that would be a perfect angle in between them is called the normal. Now, when we were reflecting, we were only really drawing it on this side because we didn't care about what's happening over here. But now that the light is traveling through the object, we do care. But that line is still called the same thing. It's called the normal. Perfect. Now let's get rid of this one because we're not talking about reflecting. We're talking about refracting. So far we got incident ray, a normal, and our answer key over on this side of our page right here. It tells us that when light enters a more dense medium, it slows down. So the speed slows down. Because it slows down, that means that it's going to bend towards the normal. So we got two options. The light can either bend like this and change direction, or it can bend like this and change direction. Take a second to make a guess as to if it's bending towards this normal or this side of the normal. Alright, if you guessed this one, unfortunately, our winner is this one over here, is bending towards the normal on the side that the light is going through. Now, take a second and pause this video because this diagram that we just went over looks awful lot like this one that is going on your page right here. So on our page you said that air was where our light was starting, and we know that air is not very dense at all. And then the light was going to hit a piece of glass and travel through it, and the glass has a lot more particles in it than the air before, so it would be moving to something that is more dense, and it would slow down, bending towards the normal. So if you're having trouble with question number 1, take a look at this diagram right here. It'll help you out a lot. And we are going to do the exact same one for 1B, so the diagram for 1B. And that one is going to look like, let's get this down here, let's get our notes. Color-coded, of course. When light enters a less dense medium, let's do turquoise this time, less dense medium, now it's going to be the opposite, oops, pardon me, it speeds up. So students having issues here. It speeds up, actually travels faster. So let's get another diagram that we could draw. So we need our object that is going to be passing through. So you can think of this like, instead of light going from air to glass, you can think of it going from inside of glass to the air that is outside. So let's actually draw from the glass our starting ray. Bonus points if you can remember the name of your first beam of light, where light is coming from. Let's go just regular black. This is our incident ray. And we know that there is going to be a normal from before, and our normal was our line that was right perpendicular, or right square, to where our incident ray hits our area. So let's there, I've got to move it up a little bit. Okay, there we go. And let's label that our normal right away here. All right, make this a little bit shorter. All right, so on our last diagram, we also took a look at what the light would look like if no refraction occurred. Oops. If no refraction occurred, or if no bending occurred, we can call this the path if not altered. So if there was no change in densities, your light would look something like this. But we know that because of the change in density, something is going to happen. In our last one, we had this little cheat code on the side there, and we're gonna put that for this one as well. So let's start over here by saying, now if it is speeding up as it comes through, it's going to equal bending away from the norm. Let's make that a little bit bigger because that's really, really important. Whoa, 200. Let's go 20. All right, speeding up. If light is speeding up, it means it's going away from the normal. And the last one I gave you two options, whether it would be coming out on this side of the normal or that one. So if it's going away from this one over here or away from this one here. Now, the answer is that it is moving away from the normal on the side of the light that is passing through. So we see our normal, if our path was not altered, it would come here. And our normal on the same side, so you can imagine that you cover up this side over here, and now you're just worrying about what's happening on this side right here when you're deciding the path of the light. So bending away from the normal, meaning it is going on the other side of the path if not altered. So it's going right there. And that is what you can draw for number 1B of this page right here. Now, that's all we're going to go through today in this video. So your job for today is to complete the first page of your worksheet on refraction. Now, if you feel comfortable and you're going to work through onto the back side, that is awesome as well. But we're going to go over a couple of those later on this week. All right. Remember that when you're drawing your ray diagrams, you always need the direction that the light has traveled, which is indicated by the arrow. All right, one last tidbit. All right, I hope to see everyone again soon. Any questions, please email me, contact me. I'll set up a video chat to give you help whenever you want during the day.